Alright, in this section we're going to be talking about properties of logarithms. The first one we're going to do is the product rule. This is log base b m times n. So that can be rewritten, the multiplication of these two and the argument can be separated by addition. So we'll look at these two examples in this next part to rewrite this. So this could be broken apart to be log base 5 of 7 plus, because this right here is a multiplication, it's hard to see. So the multiplication of these two can be rewritten into two separate logs. So we can get log base 5 of 11. So these are equivalent. Okay, using our property. So let's do the same thing with number 2. This is like 2 times x, so we're just going to get log base 2 of 2 plus log base 2 of x. Now, can this be simplified any further? Yes, if you think back to the previous lesson, we have a rule for this. So when this matches this, the answer is going to be the exponent. In this case, it's a known 1, so this actually simplifies further to just be 1 plus log base 2 of x. Okay, so next we're going to look at the quotient rule. So if we have an argument m divided by n, we can rewrite that using subtraction. As long as the base is the same, we always have to make sure that the base is the same to be able to use these properties. So don't forget to check that. So let's see some examples. I believe I have some on the next page. So we could rewrite number 3 using our property as log base 5 of 7 minus log base 5 of 13. These are very basic properties to start. Let's do the same thing in number 4. Let's rewrite. So the natural log e to the 3 minus, because it's a division, natural log of 5. Now, what did we say the known base is of a natural log if it's not showing? Good, very good. It's a known e right here. So with that in mind, what about this property? That simplifies to be just 3. Good. And we just have natural log of 5 over here. Okay, and the next rule we're going to do is going to be the power rule. I'm actually going to rewrite this one because it's hard to see in that printed. Log base b m raised to the p power is equal to p log base b m. And what happens is basically we're able to take this exponent and move it out front. And it's hard to tell that that's an exponent. It's not very good. This is actually an exponent p. Okay, let's, number 5 and number 6, practice using this power rule. So this means this exponent can be moved to the front and we get 7 log base n x there. Alright, number 6, we need to rewrite this because it's not in an exponential form. So this is in the sixth root of x. So we want to rewrite this first as natural log of x raised to the what power? 1/6 power. Now that that has an exponent, we can use our power rule to say, okay, we can bring this exponent to the front and you would get 1/6 natural log of x. Okay, now using the 3 properties we learned, we want to first learn, work with expanding logarithms. So we have this condensed version and we want to expand it out as much as possible using our properties. Well, first of all, I see that in my argument there's multiplication and there's also an exponent. So first of all, let's work with the multiplication and expand this thing out using an addition. So we would have log base b of, because the base is b for all of them, we're able to use these properties of y plus log base b of z to the fourth power. Now, there's nothing else we can do to this one, but what about this particular one? It has an exponent, so we can use the power rule and move the exponent to the front. So now our expression becomes log base b of y, I'm going to leave that one, plus 4 log base b z. This is the expanded version. Okay. Let's do a similar expansion using the properties using for number 8. So first of all, this one has division. So there's a couple of things going on here, but first let's rewrite it using division, and then we'll look and see what we need to do next. So we will have log base 5 of 25 minus, because this was division, log base 5 of the square root of x minus 1. Now, can we rewrite this to possibly fit one of our previous properties? Yeah, how can I rewrite 25? 5 squared, right? So let's just see the log base 5. This is 5 squared. All I did was rewrite 25 as 5 squared for this step. Okay. Now, over here, can I rewrite the square root? This x minus 1, instead of writing the square root, I can just raise it to the 1/2 power, which then we have a power rule that lets us do this. So let's take this next step to simplify everything. What happens when this matches this? The whole logarithm simplifies to the exponent, so we get 2 minus, and then over here we use our power rule to move that 1/2 out front, and this is going to be our final expansion. Okay, number 9. Remember that we can rewrite this as separate that into individual, the numerator and the denominator in that sense, which might make it a little bit easier for you to expand. So because this is division, we rewrite this as natural log of the square root of x minus natural log of the square root of y. Now, how can we rewrite these square roots? To the 1/2 power. Good. So x to the 1/2 power minus natural log of y to the 1/2 power. Excuse me. And then we can use our power rule to do that. So we would have 1/2 natural log of x minus 1/2 natural log of y. Okay, so in this part we practice taking the condensed version and using our properties to expand it. In the next section, we're going to take the condensed version, we're going to work on the expanded version and condense it. So we're going to basically do the opposite. Okay, so we're condensing these and we're evaluating when possible. And so we can see that these two expressions have an addition sign between them, but the most important thing, you make sure that these have a same base. Log base, what's the known base of this? Good, there's a known base 10. Remember, it doesn't have to be shown. It's known to be 10. So because these are the same base, we can use these properties. So the addition can be rewritten using multiplication. So this is the same as log base, the known 10 of x times 7, or it's just most often we're more familiar with putting the 7 first. So although it wouldn't be correct if you had x times 7. Okay. Number 11. First of all, let's take this and rewrite it, moving our let's do our power rule first. So we see this, instead of being up front, where can we move it? Yes, as the exponent. So let's work with that one first. So we have log base b q raised to the 5th power minus log base b of r. Now because we have no coefficients in front anymore, we're looking at log base b, log base b. We can now condense them using our quotient. So this is log base b of q to the 5th over r.